Good morning, good afternoon, everyone. And actually, we are sharp at good noon. So it's very rare to see people saying good noon. Good noon, all. And I'm so glad to be here yet again to inspire people in the industry. And I've been doing this as a very passionate hobby for the last decade or so in democratizing AI. And this year, we are going to have something very interesting. The idea is about Agentic Knowledge Augmented Generation. And allow me to quickly bring up a poll for you guys so that you can join in. Scan the QR code and please join. Hope you can see my QR code. And let's move in there. Yeah, hit that like button. I hope you have. Yep. Okay, so let's start with an interesting icebreaker and then we'll move on. So I see 50 of you who have joined in. Let's quickly go through. It's going to be a power-packed 50-minute session, and the first question for the day is, have you ever worked on generative AI? Because last year, when I was looking at these stats, it was very interesting to see the patterns. Let's see how it looks like this year. Okay, 90% of you are already working on generative AI. It's like the number is going even above that. Let's look at LangChain, one of the most popular open source frameworks. How many of you have worked on that? Okay, we see that 90% slightly dipping to 60-ish. It's touching 60. Okay, it has touched 60. With that mark, we'll move on. Now, have you ever built a RAG application? Retrieval-Augmented Generation application, which is one of the sexiest use cases on planet Earth today in people using generative AI in serving enterprises. Again, the same 60, which means it's tying up with the previous number. A lot of people using LangChain are also using for RAG, perhaps. And the most important question, have you ever worked on AI agents? Because the whole theme of the day is going to be, the theme of the conference is also going to be on AI agents. And we see fairly 55. You see that 63 number has dipped, which means most of you are already working on AI agents and also some 10% difference. Now the billion-dollar question for the day, and this is what I really wanted to bring on stage today. Have you ever worked with knowledge graphs? That's the number I was looking for. And thank you very much for taking that poll. And it's time for me to really show you a quick knowledge graph. If I tell you what I've been doing all these years, and instead I represent this as a picture. See, I'm Arun Prakash Asokan. I've studied at ISB and BITS Pilani. I work for Novartis, and I'm presenting a session on Agentic Knowledge Augmented Generation and also a workshop on Agentic RAG on the 23rd. So this is a mini knowledge graph. We saw the icebreaker, and when I was doing the same vibe check in 2024, we had 72% of the people who were working on Gen AI. Now you saw the numbers. It was over 93. And we had LangChain users which were fairly similar, 60, 60. You remember? And now when you look at have you ever built a RAG application, this number was also the same. So I'm quite shocked by the statistics similarity we see from the last year. When I asked how have you ever worked on AI agents the last year, which was the emerging field back then, we had 63% of the people who never worked on. Now that's the theme we are going to look at this year, but an extension of the agents with knowledge graphs augmented, which almost 80% of the group haven't even started with. So this is how I've been evolving through the years. 23, the talk was primarily on building advanced RAG applications with a finance copilot in place. And there we were looking at several internal, external data sources, how we put something together in an enterprise setup like that of finance, with the domain that of finance, highly regulated. How do you put something in production? That was the challenge. And 2022 November is when things were getting popularized with GPTs. Now, 24, the last year, 6 months before that is when agents were just introduced and getting popularized. And that August last year, we spoke about how to put things in production on Agentic AI and looked at flavors. Now, when we fast forward 2025, now we are here. The topic for the day is Agentic KAG, and I will tell you everything about Agentic KAG in the next 40 minutes or so. We are focusing on the next big theme. Trust me when I say this, the graphs have been one of the topics which has been very close to my heart all through my career as a data scientist last 16 plus years. I've been fascinated with graphs. Now that has touched generative AI big time. Yes? So what do we discuss today? Quickly, the flow of the day is going to be like, First, I'll tell you how the RAG has been evolving over time. Then we look at what is this knowledge graph, and I believe 75-80% of the people here are not aware of that. Then, how do we spice up the game and build something called a graph RAG? And then, how all these come together as an agentic knowledge augmented generation and why it is powerful. Then I'm going to tell you how are the building blocks for building an Agentic KAG solution. You know what did I do? And with my beloved team, we crawled the DHS data, the website that you all have been seeing all these days, the agendas you have been looking at. That is the data which was used to demonstrate the power of knowledge graphs. I felt that is the data which all of you in this room should be able to relate to. And how did that knowledge graph look like after we built that? And then, how do we bring in the power of graphs into the whole game and retrieve stuff from that? And we have been, of course, evolving over the last couple of years. How is the evolution framework looking like? What are the hard lessons learned? What was the hard work like? And what were the challenges? It's very important for me coming from the industry to highlight these aspects, and we'll see lots of demos. Yes, so you have a dedicated half-an-hour Q&A at 1 o'clock. Let's move on and focus only on the slides and stay with me. The first topic is RAG. Should this even get introduced? No, we already know this is one of the sexiest frameworks. People have been building RAG solutions. 85% of the use cases on planet Earth are RAG use cases, and that's what is easy to build. But beyond what you see on slide, and beyond the 5-minute YouTube videos that you see out there, things do not work the same way in production. So when you take the data, you chunk them, and you build a vector database for your own enterprise. That is the backend process for indexing. Now, you also have to be ready for a retrieval setup. So whenever a user query comes, we try to convert that into embeddings, and we try to use the same embedding model, go to the same database, vector database where all this data has been indexed, and then you try to retrieve the relevant context. So the power of large language models is already well sold to people and to the business leaders. Now your domain data is what that was missing all this time. So we created our own enterprise data, indexed them, and kept it separate. You retrieve whenever that is needed, and you augment to the required LLM's context as per the question, and we just ask it to infer on the fly. This is your question, this is your context. Now, why don't you answer me? That's where the power of LLM comes, and we don't need to build models from the scratch anymore for your enterprise virtual assistants or chatbots. Fair enough? This needs no explanation. Now, the second level of maturity is where last year we were talking about Agentic RAG, and in fact, people are still trying to build more Agentic RAG applications. The workshop that I will be delivering is also going to be centric on Agentic RAG. You see here, we put an autonomous AI agent here. Now, this autonomous AI agent is going to think, reason, and act like a human. So you give it a task like, hey, take this query, figure out what is all that you need. It goes dynamically to the respective data sources, which are given as tools, which could be a calculator, which could be an internet search, which could be something like go to a particular finance data or a CRM data and bring the relevant context, and then seamlessly give it to an LLM. So this is smart, definitely smarter than the previous setup. We can make it much more smarter when we put a multi-agent RAG setup. One agent, great. Put multiple guys. Each one is an expert in one thing. So the first agent kind of acts like a supervisor dude. He says, hey, you go and get this data. That agent calls retriever agent A, he brings the data. And similarly, retriever agent B. All these guys can even act in parallel or in a sequence. You can orchestrate that. That's where frameworks like LangGraph, which are agent orchestration frameworks, help in how you connect that. You know what? LangGraph is also graph-based. Graphs are everywhere, guys, right? Now, coming to the main story. The power of Agentic RAG is something that we completely appreciated, right, in putting things in production in the last whole year. And this year, the big theme has been Agentic. It can go multiple steps. It can act like a human for a question like, who is this person and what did he do 10 years ago and what is he doing now? For all these different parts of the question, you won't have a document which is answering all of that. But you need a multi-step retrieval. So that is what is the job of an agent. It is capable of doing that. Then it can dynamically choose the tools depending on the need. You don't need to program them. You just use the power of LLM to make dynamic decisions. It's like running in a for loop, right? I run a for loop, I just make a decision, I do that action, I observe. Then if I have to remember what I have been doing iteratively, I need a memory component. So Agentic RAG is powered with that. And last but not the least, it automatically can validate and self-correct if the answer is bad. It's like me writing a poem and crushing it and throwing it away and starting all over again, right? This dude can do that. That's why Agentic RAG was becoming so popular, and all our production solutions are Agentic RAG based. You know what? The game spices up. But if you appreciate these problems, only then you will appreciate how it gets spiced up. There are loopholes in the system. First thing, your documents are separated or kept disparate sources. They are there as one chunks. They don't talk to each other, right? They are not really connected. That's how your unstructured PDFs are, right? And if you ask a question, who is a speaker at DataHack Summit 2025 who's also working at Novartis and who has also worked at Nielsen, who has also studied at ISB, when you put all these things together, right, that multi-hop reasoning, even an Agentic RAG struggles, right? And it doesn't have the entire domain knowledge of your whole business that you're dealing with, right? It's documents. To it, it's a black box. You take it, you put an AI girlfriend document, it's going to treat the same way, correct? So it doesn't have that structured thing, data behind the screen. And most importantly, whenever you get an answer, does an LLM ever tell you how it arrived at that answer? Now we have reasoning models which are capable of doing that. We are still seeing the emerging stages of it. But when you build a RAG system, how will you explain? That is another big problem. And without explainability, serious enterprise setups will not accept solutions. Big deal, hallucinations. We should not really complain about it. Ideally, it's a blessing in disguise. This is what the LLMs are good at. They are good at making stuff. That's why it's called generative AI. But when it does something in an enterprise setup, that's where we don't like it, yeah? So we start complaining as if we had systems existed like this for the last century, right? So we have to handle it. We have to live with it and handle it, yeah? And last but not the least, you have to connect the disparate facts which are out there, spattered across your domain, and all of these are not possible in a RAG system or a traditional RAG system. That's where introducing Graph RAG for the day. Graph RAG is nothing but a RAG. It uses a knowledge graph as the backbone. The scaffolding comes from the knowledge graph behind the screen. The documents you had, the disparate documents, when all of that are kept as a beautiful knowledge graph, that's how it becomes a Graph RAG. Now the R component of Retrieval-Augmented Generation, instead of a mere vector database, what if there is a knowledge graph? Yes? That's the story we are talking about. And what is even a knowledge graph? You all have been thinking through this topic. It's there in the term knowledge and graph. Before we look at that, we need to appreciate how we evolved over the last decade and a half. We started with searches which were merely keyword based. BM25 algorithms, one of the most popular keyword search algorithms. You search for something, you were looking at only keywords, but it was not good enough. We were again wanting something cool. That's where Google came up with the PageRank algorithm. This completely changed the way Google search worked. Remember the PageRank? I believe most of you know it. 2000 is when it was introduced. Again, Google came up with that amazing idea, graph-based ranking algorithm, depending on the incoming and outgoing pages. Fast forward, 2012, again, Google came up with knowledge graph as an idea. So you see the age of this term knowledge graph, right? This is where they came up with such a cool paper introducing knowledge graph, things, not strings. We are talking about things. Everything is communicated in this one line in the paper. So you see, when you now look at what the era we are in, the LLM era, we know what AI can do. It has touched the masses. Now, what I feel is, we need to take the game further and build this new era of Graph RAG in a very interesting way, in a very conscious manner, on how we bring in the best of all the worlds and see this evolution, and we being part of this evolution. Now, Google search in 2012 changed like this. This is not a search from this year. This is how, behind the screen when you search for Marie Curie, see all these things on the right-hand side. You know how these facts are coming from? These are from the indexed web pages. These facts are already mined and kept in that knowledge graph. That's how, boom, in a second you get that answer like that, right? It also helped in, PageRank helped in sorting the best pages. Knowledge graph again helped in picking the information fast. That's how the game is changing. Now, it's time for us to appreciate the power of these technologies, right? I'm not going to bring something that is not in production. These have been tried and tested, and they are proven to bring in some 55% plus accuracy over and above all the past systems. So we are looking at an opportunity here. Yes, keep this in the opportunity side. Now, coming back to knowledge graph, some of you were wondering what a knowledge graph is, right? It is a beautiful representation of your real world as a graph. Now, this is the schema of us sitting here. DHS is happening, conference is hosted at a venue, and the conference hosts sessions. There are various sessions. One of it is happening now. And we have workshops also being hosted. There are these dudes called speakers and dudettes who are conducting these sessions and workshops. They studied at an educational institution. They work for a company, and the whole event is sponsored by some sponsors. And these workshops and sessions, they use something called tools and topics. Knowledge graph of DHS 2025 and every other damn conference you will see out there. See, this is the schema that we are talking about, right? Now, when you look at all these colorful nodes, they are nothing but entities. They are representation of you, me, a dog, a cat, any Tom, Dick, and Harry in this world. Any speaker, any workshop, any tool, any technology that you're learning, everything is represented as a tool here. Now, if you see a tool, it's an entity. But something like LangChain, something like Neo4j, all these are ChromaDB, all these are example of tools. So you can imagine this is like the blueprint. Now with this blueprint, if you create 68 sessions, that's the exact number of sessions you're having, 8 workshops, 8 venues, all these when they blow up as a graph, which I'll show you, that is what becomes a full knowledge graph. Now you see connections between them. It's nothing but how the interactions among these nodes look like. That is how you see relationships. Now to put all this into perspective, let's go to the real knowledge graph that we have built, and let me show you how our graph RAG looks like. Okay, now I'm here. Let me, hope you're seeing my screen. Are you? You know what? This is me. I am a node, and you see from my things, it has mined for the awards. This is my bio. This is the embedding. This is the LinkedIn URL, my name, and we have some properties. If I click on this, you will get to see, oh yeah, this is my graph, and you see there is also this Agentic RAG workshop, which will happen on the 23rd. This is Agentic Knowledge. This is the session we are talking about. And this is my educational qualification, all of that. Now, let's say we want to explore our session further. Now I click on this, boom, that's how it gets interesting. You see, this is our Agentic Knowledge Graph session we are at, and it's happening at Gemini, and it is hosted by this Analytics Vidya of DataHack Summit. And we are talking about covering a topic called knowledge graph. And I hover on this node, I get to know this knowledge graph. We are talking about Agentic KAG. We are also going to talk about Agentic traceability, and we are going to deal with graph database. And you know what? There is also this workshop. Now let me click here and let me see how that opens up. Oh yeah, there seems to be an interaction effect between the two. Even a concept called graph RAG is covered on this workshop as well as on the talk. Okay, is there any tool which is common? There is this tool called LangFuse, which is for agentic traceability, which is being common between the two. Similarly, Neo4j is this popular graph database. You didn't even go through the data. You didn't even see the website. I didn't even tell you what am I going to cover. This knowledge graph has covered everything that is going to happen with me and all of you in the next few days, right? And most importantly, all these interesting concepts you can imagine who else is also covering, right? If you take something like AI agent, if I click, boom, it again expands to know what are the other sessions. Now you can already mind map this, right? Where I'm heading to. You have mined for all of this and put this connected world as a knowledge graph. Now when this sits behind the screen, what happens is the point, right? Now coming back, in this thing, of course I showed you, with my node you see a lot of things. These are called properties. You can add any number of properties. Now this is a small graph. When we blow it up to see, we can also see all the connections. Now when we look at common topics, common themes, that's where interesting insights will emerge. Yes? So the power is appreciated. Knowledge graph helps us with standardizing the data. It's very flexible. You can keep on adding, modeling your real world, and you can build context into your system. Graph RAG is spicing up the game by leveraging that knowledge graph by bringing in explainability, accuracy, and you can bring in full governance on how things work. What is the theme for the day? Agentic Knowledge Augmented Generation. This is where I want to bring in our beloved AI agents, bring in our knowledge graph, the power of it, of course in a RAG setup, and give life to something called an Agentic Knowledge Augmented Generation. That's why I call it as Knowledge Augmented Generation. It's not Retrieval-Augmented Generation. Fair enough? Time for us to look into the 3 big components in building an Agentic KAG system. The first thing is, of course, you need to build a graph, isn't it? It's tedious. And I can show you how I did that by crawling the AV data. This took 60 to 70% of the time, and it was taking a lot of efforts, right? But there are interesting packages from like Neo4j and similar offerings from other graph data providers, which will help you to simplify things. The second thing is you need to build a strong retrieval system. And you might wonder, we have been building retrieval systems in the past. What's so cool about this graphs behind it? That's what I would like to highlight. The third thing is, how do you orchestrate all of that as an agentic setup? Fair enough? Clear? These are 3 components we are going to see now. Let's build a knowledge graph on our DHS data. First, at a high level, I'll show you the steps involved. We take the web pages, something like that of mine. There is a speaker page for me. Now, when you crawl all these pages, it looks like a web page, HTML. We do something about it and use the LLMs to extract entities and relationships from the data. Power of LLMs. That's why knowledge graph existed since 2012. Why is it so popular? Why am I discussing about it now in 2025? Bringing in the best of multiple worlds, right? You have LLM gods which can help us in mining for entities and relationships, and that becomes a knowledge graph. It's at a high level, but I will show you the end-to-end flow. Don't worry. The first step, we start by crawling all the DHS pages. The next step, once the data is crawled, if there is a need, we can chunk. I didn't see much need for chunking here because the content was relatively small enough. So the whole web page was converted as a chunk. What is a chunk? That is what is treated as a small document in your vector database. Now, we create embeddings for the chunk. That's fine, that's part of the step 2. Step 3 is you need to define the schema. Remember the schema I showed you? Venue, sponsor, speaker, workshop, how all these are connected. That little graph I showed you, that is the schema. You got to define the schema. But what if you do not know anything about your data? How will you define? Now we know DHS data, so I defined it. So I'll explain that when we go to the code. After that, we will try to mine for these entities and relationships. Yes? Once those are mined, we try to disambiguate the entities. Example, Arun has a speaker page. Arun also has a session page. There is also a workshop. Now each of these websites will crawl and look for this node Arun, and they will be sitting as disparate chunks, right? Now how will we combine all of them? Else how will the graph look connected? It will look as subgraphs, right? There is going to be a subgraph for a session, subgraph for somebody, subgraph for another guy. Only when we combine all the AI agents, combine all the AI RAG concepts, and combine all the topics and tools, it becomes connected. This is such a difficult step, and I'll show you how that is done. Then we can build something cool called communities. We can cluster people who are participating, and we can build something called communities, and finally you have a knowledge graph. Yes? So this is how you finally make a knowledge graph, and after that you have a database called Neo4j, in this case what I've been using, a community edition of that, and it's been stored there, then we index it. So this is at a very high level. Let me quickly show you, very quickly we'll skim through the code. Of course I'll share the codes, don't worry. Yeah? So we'll go through yes, spot on. Fair enough, can you see this whole screen? Is it legible enough? Okay, so you know what? First, we do the setup of crawling. So for crawling, of course, all the essential packages, I use Beautiful Soup, yeah? Now, we set up the crawl configuration, which is Beautiful Soup, what should be the length, breadth, and all of that, and we crawl the data, then there were issues in the data. So this is data preparation, manual filtering of pages. There were some dead pages, there were some pages which were mismapped, and then we finally make all that HTMLs which are crawled to a markdown. Yes, that's what we do. So for that, the idea is we start with the main page. Of course, you don't want hack summits from the past. You want only the current one, right? And having a base domain for that, and these are all the supporting functions. Then when you do this web crawling, also these are the dead pages which had to be removed. And then when you run this, it started crawling one after the other, and finally we ended up having how many? It kept going, and also you see, there were certain pages which didn't have much content, so those were removed, and 157 pages were crawled. And this is finally beautifully converted as a HTML and, as a markdown, and then we have a clean data which is now pickled. You know what? Agenda data is there now. Website that didn't have the agenda data initially, so the agenda was taken manually from the organizers. So I took that data, and this kept changing as well. You can imagine how often this changes. Till this morning things were changing. So this was again added as a chunk, and this has information around this room, this time, and all of that. So this is also connected. That's how it becomes a knowledge graph, right? Interesting knowledge graph. Else things are not connected. So this is how, when all of that is put together, it is now dumped. As an example, this is how the first page looks like. Now let us look at how we convert this into something called a knowledge graph. So this is where I would like to leverage a package from Neo4j, and Neo4j is one of the most popular vector databases plus the graph data in it. They are primarily a graph database. Now they have added a lot of vector capabilities as well. So they are doing a lot of research in this space. They are pushing GraphRag a lot. Of course, this is one of the things which I strongly recommend to start with, in the space of graphs. And then of course the usual stuff, right? Setting up the LLMs. Tried using GPT-5, which is just around the corner the last week. Now, this is how the pipeline looks, guys. Let's take a quick look at it. We see there is a document, we load. If it is a structured data, like Excel, or if it's unstructured data, like a PDF, we load, we split it, we embed the chunks. Usual, right? What is so cool? This is where the beauty comes. Entity relationship extraction. So you look for something called a schema, which is like telling this is what my data contains. You can actually use something called an automatic schema builder. That will help you with the first cut. You can automatically mine for all the data. It can mine the schema for you. Power of LLM. If you know the ontology already, which is like if you are having a rich domain expertise, if you are having a very proprietary niche business, you have your ontology, you have that definition of schema. If it is a document, you can also build something called a lexical graph. I'll show you that in a second. Now, this stage is where all the magic happens. You mine for all the entities and relationships. The graph is scattered. It has to be pruned. It has to be nicely trimmed to have a beautiful garden. Then we finally resolve for all the entities which are duplicated. Remember I told you multiple pages. Finally throw that into the Neo4j Graph DB. So this is typically what we do in these steps, right? What I'll do is, I would also like to show you some schema that is defined. You see, this is how the manual schema is defined. And you might wonder, how did I arrive at this? Of course, an automatic schema run with the Neo4j Graph Database package was done, and I got it. And then we enhance this. You see, these are all the profiles of a speaker. In a workshop, you can have something like a prerequisite tool, start time, and you can have this session which can talk about themes, tools discussed, the intermediate levels or the advanced levels, and with the date and the day. You see where this date and day comes from? Agenda, yes. So this is also the venue. Finally, it goes on to sponsor, company, education institution, conference. Now that is the node. This is the relationship. You see, sponsor sponsors a conference, speaker presents a session. These are the relationships which are defined. Now you tell, this is what I would like to see. You find out and then you put it into my structure. And this is all the possible patterns of relationship that can be there. If someone already has this knowledge, that is what is recommended. Now you put all this as a manual schema, you send that to Neo4j. Now, we are dealing with content which is from the DHS website. What if it is a PDF document? A document can also be chunked in our traditional styles, and you can have chunk one a part of document as a relationship. You see, you can also build connectivity among all the chunks with this lexical graph. This is called a lexical graph. But what we are building is a property graph in this session, right? So something like in the context of movie, a director directs a movie, and an actor acts in a movie, which is part of a genre, and then the user rated. So this is how the property graphs look like. This is another type of graph. That's what we are trying to focus here. Next up is the entity relationship extractor. Beautifully using an LLM, we can do that. You see what this has done. It has mined for all these entities and relationships from this data. And I can go on and on. You see, this is the whole DHS 157 pages that have been crawled. And thanks to all the LLMs and the cheaper context windows and the 272,000 context window we have got in GPT-5, and that's what helped us in mining for all of this. It keeps going on and on, right? So this is the step, right, where we need to actually be keeping close attention on how it is doing. But you know what? After it has done that, it may not look very, very nice in the get-go, okay? Let me show you how it starts. You will initially, when one of the graphs I built, it started with 2,729 nodes. Then, after I tried to disambiguate the entities, Aruns which are similar, the same name repeated across. Further in the process, reduced to 1,200, reduced to 1,018. Then it further reduced to something called 600 in one of the variants that was built, right? But you know what? This process can also be automated with some algorithms. You can look for similarities, you can look for fuzzy logics, right? Now, this is how the graph looked when I first built. You see how it evolves over time, like how a baby forms from a day to day to a month to a month. You can see that nodes getting reduced. You see, now the head is formed, now you see the body is formed, now slowly you see the graph is beautifully formed. It looks for topics. Oh, there are a lot of topics which are similar, I can even combine them. Now there are a lot of tools also which are similar. Now let me combine them. There are speaker roots which are similar. Finally, boom, you have this beautiful graph. This is how it slowly evolves, and stage by stage. This is a multi-step process. It can do mistakes. That was the challenge I had to handle, right? Now let's see this DHS KG in action, which is the knowledge graph itself, right? And this, I believe you guys have already got exposed to. Let us start with our DHS graph. It looks like a simple node. When I click at it, it should ideally boom and show the whole family of all the seasoned speakers. It's happening at Leela Bharatiya City. This is a community where all of these guys are belonging. Now when you take and further, if I remove this limit and if I run it, and if you see the graph again, you should be able to see a better picture this time, because it kind of tries to show. This is one level. You can further take one level at a time and you can keep expanding the graph, right? And you can find interesting insights like, okay, there is a person who's part of a community. Now community is also built. And there is some gentleman who's speaking about VO. And if you want to see this entire thing as a schema, you see on the left hand side, you have this different things. There are people from these many companies who are speaking at the conference. There is just one conference, but people from these many educational institutions are participating. And there are some 25 tools. I mean, here it is restricting it to 25, but actually it is much more than that. And when you, likewise, you can completely explore the knowledge graph in one form to another form. Let us see the whole graph, right? Let me show you the entire graph with all the connected. This is what is a cipher query. Now, just like how you write a SQL query to query a relational database, this is a cipher query. It kind of looks at match the nodes which are connected with the relationship to any other node. Return the node, which is an alias n, and return the relationship r and return m. And this is a huge graph, so it takes time, and we are on limited hardware. So let's really hope this pops. But in the meantime, I can show you this is how the graph would potentially look like. I believe it has come. There is data cannot be out of memory. Okay, so let me show you the graph in full scale. This is how the graph typically looks like. Okay, now we have built it. Let's speed up. We have 18 minutes. Let's speed up and let's see how this is going to the next step. So you fairly understand what is the knowledge graph and you know how the DHS data is. What do you do with this? You got to retrieve data from this, right? How do you retrieve and build a strong retrieval system, right? In this case, very famous concept of a hybrid search. You start with vector searches and full text search. Hybrid is what? Two, combination of similarity search and full text search, BM25 algorithms. You get the nodes, the entities which are closely matching on the similarity on the top, and then you have the matching nodes. Then we normalize them because they have some scores, right? The similarity scores. We divide that, we do a min-max normalization, and we get this normalized scores. Fair enough? Now the nodes are normalized. We combine them and you re-rank further, you get the top nodes. These are all the nodes. So is it ringing a bell, people? Hybrid search? We all have been doing? What's the fun here? We are doing with graph. Okay. Now behind the screen there are embeddings created for each node. You should not forget that we created embeddings for each node and we added it there. Let's leverage the coolest power of graph now. Now listen to this and watch this slide very carefully. The whole thing is about, watch the colors, right? We start with the user query. Now we do a vector search and a full text search. That results in these nodes, and we try to find something called a normalization across all these nodes, and we get this middle layer. After that we do a re-ranking and then we come here. But you know what happens? After this stage, there is something more interesting that happens. You have reached the stage of combination and re-ranking and you have picked the top. Power of graphs jumps in now. You take the user query, the English query, which speakers are very similar in dealing with topics related to Agentic AI. Which sessions are overlapping in between Gemini and NUA? I am a lover of knowledge graphs. Tell me they build a custom agenda for me. These are all the questions that I envision, right? That English question, when it becomes a cipher text, which is like your SQL, that is text to cipher. This capability now, it's like a cipher, I showed you, right, some time back. Now when that cipher query is built by another tool called text to cipher, you give that cipher query, and that query, imagine if that query is applied on each of the best nodes which are returned by the hybrid search. That is the stage where the magic happens. you finally see all the matching nodes, and it's like these are the top nodes. Now on each node, let me run the cipher query, and I'll get insights, and I will do graph traversal from the best nodes. I will see the neighbors around it, and that's how it becomes knowledge which comes out of this whole thing. You know what? This is called a hybrid cipher retriever. A very cool concept, right? And finally you have the nodes which are matching along with the additional nodes, and all of that are connected and given to the context window. Yes? Fair enough? Now, what's all that is the power here? Let's appreciate it. First, it can do multi-step relationship analysis. None of the previous techniques can do. We can look for combining evidences from several smaller graphs. And the graph algorithms are also there. We can find page rank, we can find centrality, we can find similar sessions, we can find the shortest path, we can find communities. There are 65 plus graph algorithms. Again, thanks to all the applied mathematics concepts which we can apply here. Then we have this concept of re-ranking, also some algorithms on re-ranking, and most importantly, when an answer comes, you can explain it is because of these nodes which are connected in my graph. You can even show the graph to the user. Boom, see this graph. This is a subgraph which is helped in answering this question. Look for yourself. If you have a problem, talk to me. I'll update the graph. So cool. Earlier, it never used to be this cooler, right? So we used to have these conversations to do the business testing, and there is always a grain of salt which is there in everyone's tongue whenever we look at these results. Along with that, the Agentic KAG solution that we are going to see today looks at one more cool concept, which is from the Microsoft's implementation of the Graph RAG concept. They are also big advocates of Graph RAG, and they came up with a great paper, and that is adopted by companies like Neo4j, MemGraph, and many other GraphDB providers. Local search, you saw hybrid cipher, that is from Neo4j. But this one is user query, you find the relevant nodes, similar to a hybrid search, right? Next you do, if there are texts associated with that, we bring that chunks, traditional RAG style. If there are connected relationships, if there are connected entities, if there are connected communities, you bring all of that, you re-rank, give it to the LLM. Now this is a very, very rich local search. The question is about an anchored node. You take one node, you get A to Z about that guy. Yeah? Makes sense? But there should be something called global search, right? What about thematic questions? Questions which like go to the sky level. You take a question, you search for the multiple communities you have built. It's like clusters you have made. We have 30 clusters that is built out of the DHS data. Now for each of those clusters, you make the answers, you combine all of them, you generate a final answer. That is how global search looks like. Now you know what? The Agentic KAG system we have built looks at hybrid cipher retriever, text to cipher as a tool, the local search, and the idea of global search. All of these are coming together in this. Put all this together, user query goes to a React agent, reason act agent concept, which came from the agentic world, a paper. Now you give all these as tools to it. At its disposal, the agent can choose which tool to use. It will do all the routing from one tool to another depending on the need. If something fails, there is also a fallback which agent should take care of. Finally, all this should be observed, right? What happened step to step from stage to stage? What happened? How it moved from stage A to stage B? What is the LLM call made? All of that is tracked using a package called LangFuse, which is for agentic observability. Let us now see all of that in action. 0.3. Let me do one thing. I'll quickly show you this demo, right? Which I feel is very, very interesting. And rather than keeping, okay, can you see my screen? Okay, now we are able to see. Yes. So the question is, who's Arun? And behind the screen, you see, this is how it worked. It went in and it looked at multiple retrievers for the simple question. Even a hybrid retriever can answer this, right? A simple hybrid retriever. So it did all that analysis. It looked for the right chunks which contain details about Arun, and there you have the answer on who is Arun. Yeah, this is a clear-cut pull-out of my information from the agenda. Now, let's say we had a follow-up. Which sessions or workshop is he delivering? Now, it keeps going to the same lang graph. Behind the screen, all of this is connected as a lang graph, which is again from the LangChain community. Now, when you open this, there is a conversation history. The previous question was about who is Arun. The follow-up question is about which session or workshop is he delivering. So, it's talking about Agentic hack session, the one you are here sitting in this room. That is the hack session, and we also have the RAG workshop session, right? These are the two, and there are some commonalities between the two. We're dealing with graphs and all of that. Now, recommend workshops for someone interested in LLMs and LangChain. If you ask this question, what happens? Behind the screen, it looks at the whole set of sessions, and it suggests that these are all the sessions which are dealing with LangChain as well as LLM, which is coming from the description of each of those pages. You see? Now, when you take it ahead, you see there are very many sessions across multiple days. All of that is put together. In fact, this app can also be made available to you guys to play with. We are doing some stress testing. I'll publish on the forums, right? Now, when you keep going further, tell me the session that happened between 2 and 3:30. For a question like this, there is an agenda information, the knowledge graph has it. So it understands, the agent breaks that down into parts and it understands which tool to call. For this, a hybrid cipher retriever is being used because it brought the relevant nodes, then it tried to run that time pull of each of those from this. So this is how the traceability looks like. You are able to see what happens behind the screen, and of course, this involves using tool A, tool B, and it tries to move. Finally, you will be able to see the sessions. I think there was something that went wrong. Oh, no, it worked. So let me show, yes, so there you go. Finally, we got this day 1. These are the sessions that happened between them. So technically, you see, there is a component of graph which is coming whenever there is a need. There is a component of your traditional hybrid search which is also coming whenever there is a need. This is how these two are having a play. You look at this graph, this question. I'm a big lover of knowledge graph. Do not get confused with lang graph. Suggest me and make a tailor-made agenda for this. There is only one session till yesterday that was dealing with knowledge graphs, and that's why the agenda talks about only our session. Now, when you look at little broader aspect, right? When you try to look at which are the other topics which someone can build a custom agenda for, I asked for, can you build something on day 2, the sessions, and give me a gist of everything. So again, this is a grill of day 2, this is a grill of hybrid cipher. It brings all the day 2, it looks at all the sessions, the agenda, and it looks at all the multi-agentic reasoning is being showed here, and this is, of course, the summary of all the day 2 sessions. Of course, one can even see the app for this, it's not a big deal. But the coolness comes for a question which spans across more than one theme, right? Look at this one. Tell me the tools used in a particular workshop and a session, which is arts. So in this case, the agent should look for all the specific tools and it should look for the sessions. It calls out these. You can look for similar speakers. You can look for other guys who are also thinking. If you want one tool in mind, you can ask for which session I should never miss this DHS. If you want to say that I am free and where are they happening, we'll bring the venue. Of course, it's talking about Gemini and La Mavala is where the location of the workshop is, right? Now, if we look at, that one last question, list all the workshops and happening at the same venue. So there is a venue node, remember, La Mavala, and there is another venue node. So this tries to bring in all the workshops. Of course, there are a few other fellow speakers who are also delivering workshop in the same location as that of La Mavala, right? So, guys, we have 7 minutes, and I believe it's time for us to talk about some challenges. Those are all rosy sides, right? So what did I learn? What are the big challenges? It's opening a new door for us. Ample opportunities. We should be cognizant of the challenges as well, right? The first thing, the graph is cool. After you build that, you need to ensure it has all the nice quality you want, because you are going to put this in production in front of business users, and the best part is it is easy to learn from the graph. If something is wrong, there are ways to identify what is wrong in this graph. So the quality aspect is critical. If there is a domain-rich data, please have a human in the loop validating, a business guy sitting with you and co-creating this. Without this, don't deliver a generative AI product, because development time is very lean. There are these challenges which we need to tackle, and most importantly, building a knowledge graph. Of course, there are many tools like Neo4j Graph Database. That's the tool I use. I will share the notebook. It's easy, but it took some good amount of time for me to get the best graph. But after I figured out that art, now give me any data, I'll be able to build a knowledge graph. I can consult on any domain, right? So that is how there is a learning curve. Invest some 1-2 months, you will understand the idea, you will get a grip of things. But first time, there is a steep learning curve. Then, most important thing is domain knowledge. Don't treat your data as black box and throw it to a knowledge graph. It will build something, but the answers may not be interesting. If you are going to build a system which is going to be suboptimal, why even build that, right? We can stay with our past years' innovations already, right? Cost. There is a cost angle. We took the data and you see LLMs are getting cheaper day by day. The context windows are becoming broader and broader day by day. But relatively there is a higher cost in building a knowledge graph. Let's admit that. Tomorrow if you tell me you built a Agentic RAG system with 1,000 PDF documents, you spent X dollars, now I give you 1,000 new documents. I treat it like a black box, I index it, my data refresh pipeline runs, and I'll have my inference pipeline using the new vector DB. Agentic RAG, cool. But the problem is, in this graph RAG, you have to rebuild the graph. So there are some cool techniques to update the graph, right? It's not impossible, but you can add timestamp, you can add extra properties, you can add extra nodes. So, but companies like Walmart are heavily invested in knowledge graphs. There are friends of mine who are like fully working on this topic. You see, can you imagine, for the scale that Walmart is, right, if they are able to use a technology like this, for the scale Google is, for a scale Wikipedia is, you know what? Wiki, Google, all these are powered by knowledge graphs behind the screen, right? And I'm not making up anything here, right? And it's not a one size fits all, right? You have to use this very consciously. You have to have all your reasoning in mind and why you're doing what you're doing. So graph RAG should not be treated as something that will fit everybody's needs. Use it only when there is a need, because I want to show you the next best thing. That's the opportunity, and we have 4 minutes. Time for us to come to this core idea. Now reflect on all that we saw. RAG, it helped us to retrieve knowledge or even retrieve data. Graph RAG connected all the knowledge, right? And that's where it became interesting. But what I showed you today is Agentic KAG, Agentic Knowledge Augmented Generation. The best of multiple worlds. RAG was cool, Agentic RAG was cooler, and Graph RAG was a competitor, right? And it was a contender. And then the ultimate tag team partnership happens between a Graph RAG and a RAG, and it's like best of all the worlds. That's where Agentic RAG reasons with your knowledge. And what is very important is, knowledge is very cool, right? That's power. But what we are seeing here is Agentic RAG is bringing in something called a superpower to us. So I strongly recommend you guys connect the dots, think through well before you solve a business problem. Ask yourself, am I doing the right thing, or am I just following the herd? Yes? So that's my QR code for a quick kind of network opportunity. And then thank you very much. So we have 3 minutes left. If you have any quick questions, we can tackle them, or we can move to other room where we have a 30-minute dedicated Q&A. I can share all that ideas, yeah. Over to you first.
Yes.
You have mic for gentleman? Please, speak. Try.
No questions. This was the best
Oh, thank you. Thank you very much. Thank you.
Nice session as always.
Yeah. Can you be louder? Can you have mics, please? Yeah.
That's okay, I'll be louder.
Yeah.
On working on the ambiguity, right?
Yes.
That was more on a manual.
Ambiguity, we have concepts like entity resolution concepts. So there is something called a fuzzy match, where across nodes we set a threshold and it runs an algorithm called Levenstein distance, and that is one round. So what I did was, first I looked for simple matches. If your node is there and your name is scattered across 10 nodes, simply merge all of them into one. So all the nodes become one, 10 nodes have become one, then it connects with all the other relationships it gets. Second round, I ran a fuzzy. Third round, it again looked for topics. I looked for topics exclusively, and I set a threshold of semantically, if there are 90% similar, then combine them. Then for tools, so I had that privilege to, that's where I showed that baby formation, right? Month to month, we see the 10th month delivery. So here in the knowledge graph setup, it quickly went and finally landed up in that combined graph. So that's why it looked as very disparate subgraphs. It all got connected as a final graph.
Hello. Here.
Sorry, we'll take it. Yeah.
Just a quick question.
Yes.
Will this be a replacement for a traditional relational database where we store the transactional data?
Of course, for structured data, the beauty is your data is already structured. It is sitting as tables, columns, rows.
But what about the scalability and updation cost?
It is when you look at the database concepts, they are ACID compliant databases, Neo4j and memgraph you should see. They are capable of handling even streaming data. So you can loosely look at a traditional database and a graph database as an evolution spectrum, right? And I strongly believe a structured data can be very well put in a nice graph databases, because entity relationship mining is already solved problem for you. All you need to do is populate the graph database. You know there is a row, there is a column like person, name, address. You can combine all of that.
Thank you.
Hi Arun.
You have a question for long,
Arun.
quite some time. Yeah. Can we? knowledge augmented generation. So here I have used a lang chain, lang graph, right? Neo4j Graph Database, and of course all these are running with a traceability on lang fuse. I think I can show you the lang fuse during the calculating session. Yes, these are the technologies behind this.